A function f from x to y is surjective if every element in the codomain y is the image of at least one element in x. So formally, we say that for every y in the codomain y, there exists an x in the domain x such that f of x is equal to y. And so let's see an example. So let's say that we have a set x and a set y, and let's say that x has 4 elements, a, b, c, and d, and let's say that y has 3 elements, 1, 2, and 3, and let's have a function that maps, say, a to 3, b to 1, c to 3, and d to 2. And we can also write it in a table form. So for every x in the domain, so f of a is equal to 3, f of b is equal to 1, f of c is equal to 3, and f of d is equal to 2. So this function here, f is surjective. So f is surjective. Why is that the case? So let's look at this carefully. So for every y in y, so this is where we need to check, there has to exist an x in the domain such that f of x is equal to y. Now what this means in terms of the picture here is that every point here has to have a line going into it. It needs to be the output of something. And that is the case. So you have 3 elements here, 1, 2, and 3, and all of them have some line going in, so they definitely correspond to someone in the input. So they are the output of someone, right? So in this case, 1 is the output of B, 2 is the output of D, and 3 is the output of A and C, but it's enough that it's the output of A, for example. As long as it's the output of someone, we're good. Another way of looking at it, if you look at the table, this column on the right has every element of y. There's no one missing. Y has 1, 2, and 3, and you can find them all here, 1, 2, and 3. That's it. As long as that is the case, that means precisely this definition here. So surjective means that every element in y has an input that takes it to that element, or in other words, every element in y is the output of some input. So let's see an example of this failing. So let's say that x now is let's consider the same set. Let's consider the same set here. A, B, C, and D, and let's consider the same set Y. 1, 2, 3, and 4, and let's say that A maps to, let's consider the same, so let's remove this. Let's say that A maps to 3, let's say that B maps to 1, let's say that C maps to 3, but let's say that D maps to 1. And so in table form here, and let's call this function g. For little x here, g of x will be, so when x is a, it's going to be 3. When x is b, it's going to be 1. When x is c, it's going to be 3. And when x is d, it's going to be 1 again. Okay, so now g is not surjective. So why not? because when we look at it now, how do we negate this? We need to find an element in y that is not the output of someone in x. So in this case, if we go over the y's, we need to find someone here that there's no line going to it. So 1 has 2 lines going to it, so it has at least 1. 2 does not, and that's it. We've identified the point that doesn't satisfy the definition. And so since there's an element in y, in this case the element 2, that is not the output of any element in x, this cannot be surjective. In the table, what this means is if I look at the column here, which again, if we look at this as a set, remember this is just the image of the function g. If we look at the image of it here, there are elements of y that are missing. So y has 1, 2, and 3 here, so 1 appears here and here, 3 appears here and here, but you don't see 2. Since 2 is not appearing, this cannot be surjective.